Well, good morning, everybody. It is December 24th, Christmas Eve, and I want to start off today's forecast video a little differently than I do my forecast videos because I'm going to be taking some paid time off here to finish out this year, and this is my last video of the week, and I thought I'd just spend this moment talking about one of the biggest drivers of our climate system for the last several years, and that's been La Niña. I want to show you that so I can show you what I think it's going to be doing here in the very near term. So you've been looking at an image, looking at what's called the Ocean Niño Index. We all like this webpage because it goes back to 1950. And every spike up is an El Nino event. Every spike down is a La Nina event. Now, we typically think of La Ninas as double dippers. They tend to come in like pairs, so 1, 2, 1, 2, 1, 2, 1, 2. Occasionally, we have them show up for a while, like from 98 all the way to 2002. So you can kind of see 1, 2, 3, 4 before we break off into a large, El Nino event. Again, a pair, and then here's what's interesting. Since 2020, when we bottomed out on our first of the sequence of La Ninas, we had 3 subsequent years of La Nina, then a big El Nino event, 23-24, and then another 2 La Ninas. We're in the sixth year where 5 of them have been La Ninas. Okay, that's what's going on in this little time period here. We have a couple of big questions, all right? The first is, are we going back up here into 2026? There's some indications that we are, and we just need to continue to monitor that throughout winter into spring. The other thing I want to mention is that, I've been kind of hung up on 2018, and if you look, one of my reasons for that is here's 2018. We had a La Nina here, and then it quickly rose to a moderate strength El Nino by the next spring. It's just a recent example of this happening. You're going, well, why aren't you using 2023 as your example? I said, because I'm not convinced that the transitions happening now are as similar to the, to 2023, where we just race up toward this so very, very quickly. So just a point of, of what's going on in the ocean temperatures and why I think it matters. Now, if you're unaware of where we get these names, El Nino and La Nina, that just real quick, the namesake for El Nino is the holiday that's about to be celebrated. So what happened was back in the 1800s, Peruvian fishermen here would notice, they've been noticing for centuries, that the water temperatures just off the coast would fluctuate on an irregular time schedule. It wasn't like you could pin it down. What am I talking about? I'm talking about this odd behavior in those water temperatures. Now, what they didn't know at the time, at least they were not correlating against that, was that what was controlling these water temperatures was the strength of the trade winds. They did know that when those trade winds got really, really strong versus really, really weak, it affected their precipitation patterns. For example, when it's really, really weak and there's an El Nino, they tended to go into drought. Okay, that was one of the things that just tended to happen. And the fish that these Peruvian fishermen were fishing for, which is mostly anchovies back in the day, they would leave because the waters would get too warm here and the fish would go to where the more colder, nutrient-rich water was. Now, they named it El Nino because they were talking about the timing of the biggest change in the water temperature. It tended to coincide with the Christian holiday of Christmas. So El Nino is a reference to the arrival of Jesus or the arrival of warm water. Now, they did not name the opposite, which is what we've been in, which is this cold phase you see here. That's called La Nina. That's just what scientists named the opposite of El Nino, so little boy to little girl. Now, we can attribute most of our early understanding of El Nino and La Nina to a guy that was from Great Britain who was installed as the Indian Meteorological Department. I don't remember what it was called back in the 1800s, but he was put here to study the Indian monsoon, and while he was studying there using some brand new mathematical techniques at the time called correlation and regression analysis, he determined that there's an oscillation in the wind pattern across the Pacific Ocean and the Indian Ocean. Now, I'm telling you all of that because what you've heard me talking about and Matt talking about and Andrew talking about for months and years is these 2 oscillations here and here. We have modern names. We call this the Indian Ocean Dipole. That's the boring scientific name that is what happens when you let a bunch of scientists name things. But then you have the El Nino La Nina over here, and it's just an oscillation in a wind pattern. And I want to show you what's unique about 2025 into 2026 by first showing you that when you look at January to November from 2020, here they are. That's all 5 of them. Okay, we don't have December data in yet, but all 5 of them, we have just had persistent cooler water on stronger trade winds. That's what's creating this, okay? Now to the north, we've had this, and this is very significant, especially in the middle of summer. Now, I only talk about summer because I'm talking about growing seasons across North America. It's been huge for winter as well. The very, very warm North Pacific has what's driven what we call the Pacific decadal oscillation, very negative during that time frame. So what I'm trying to do is just kind of match up these patterns and make some sense out of it. So with all that being said, what has it done? Well, if you look from January to November, for each one of these years, now notice I've thrown out 2023, okay? We have seen this, all right? We park the MJO here. This is anomalous precipitation rate, got it? So the MJO loves to live in phase 4 or 5. You go, well, why? Because the trade winds push like this, the Indian Ocean dipole westerly wind bursts there, and you get rising motion. You've seen me draw that 1,000 times. What is interesting is how the global precipitation pattern has responded. To be honest, most of South America's precipitation rates during these years have been below average, especially into southern Brazil and parts of Argentina. We've seen some big droughts that have developed in southern Brazil and Argentina. What is important is that even though we have a lower precipitation rate in northern parts of Brazil, or the center west, you can still have low precipitation rates and be perfectly fine on total amounts of precipitation in this area. The drier conditions are down here farther to the south. Now look at Australia. It's been wetter east, a little bit drier in Western Australia. Central Africa has been drier. We have had at times kind of a split across parts of Europe where we've kind of south of that line, or that arrow I just drew, we've been drier, including parts of the Black Sea, but wetter to the north. All right. So we look at all these things, then we come into the United States. And what's interesting about the U.S., I can kind of zoom in on the U.S. and show it to you differently, is that if you look at the composite precipitation anomalies of those years, January to November, I'm trying to look at most of the year here. I can't use December because it's not done yet, so that's why I don't have it, okay? But what I've noticed is that most of the country during this time period has been drier. Now you might say, why? Okay, why would we tend to be drier on the whole of the year? There's a couple of big reasons. The first is during La Niña years, the atmosphere tends to have lower momentum. And therefore, we tend to take the Bermuda high, which is here, and at different times of the year, it just drifts on off. It just leaves. The Pacific high also tends to be weaker and more variable. And so is the jet stream. So long story short, our jet stream is our biggest factor in our fall, winter, and spring. It's a weaker factor in summer. But it likes to do that in winter versus El Niño's where it just comes. I wish I could just draw a real fat line that goes right across the country like this. Okay, that's the difference. What I find fascinating about this is the southeastern United States, the whole of it, including the Mid-South. And one of the reasons why this looks so wet during this time frame has to deal with hurricanes. And if you look back, we've had some big ones over those years. Again, I've got them all labeled here that have sat and just hit this. Do you remember 2020 in Louisiana? This was, just think about all of the hurricanes that have come through here and dumped tremendous amounts of rainfall. So what I'm saying is they're biasing these statistics toward that hurricane season. Now, certainly not 2025, but the other hurricane seasons. We just recently remember Helene, coming through, causing catastrophic flooding as it made that turn back toward the Mid-South. Now, here's what's really interesting. Let's just pick 1 month. Now, I'm in Illinois, so you better believe we got to focus on July. The temperature pattern in July, mainly because of all that warm Pacific water, has favored a lot of heat here. Now, we've had some hot summers up the Northeast as well, but do you notice that in the central United States, just July alone, we've not had highly anomalous, let me just rephrase that, we've not had routine and regular highly anomalous temperatures. And here's the real kicker. If you look at the precipitation patterns in 2020, 2021, 22, 24, and 25, we've been wetter in much of the Corn Belt. At times, we've been wetter through parts of the Cotton Belt and over to the southeast. And I think this is just key to remember. We've had some epic fall droughts, but plenty of summer thunderstorm activity inside that circle. I just find this fascinating to kind of go back and look through and try to analyze this and understand it. Now, we are about to head into a new year. So what happened in the January to Marches of those years, just as examples? And you can tend to see we tend to be wetter in the Ohio Valley, parts of the Tennessee Valley, maybe parts of the Arkansas and Red River Valley, and of course the Mississippi, drier in California. That's one thing to think about. And the temperature pattern tend to be very mild here. Again, just looking at these particular starts of these particular years. Now remember, La Niñas always fade January to March. So we got to be careful with that. But what is this particular La Niña doing? And I think it's important for us to ask that because I think it's hit its bottom and I think it's going to fade earlier. Now, what I mean is sometimes the La Nina effect just blends over into January, February. And at this one, I think we've already seen its peak. Now, to make a point of all of this, what did that guy that was put in India figure out? Well, his name is Sir Gilbert Walker. And what he determined was in the Pacific Ocean, we typically have trade winds, rising motion over Indonesia, jet stream comes back, dives over here. All right, that's normal, okay? During an El Nino year, all right, what we tended to have is, is something like this. Those trade winds become very weak. We take all the deep convection that's here normally and shove it back over to there. During a La Nina, you just take your normal Walker cell and you put it on steroids. It's just going very, very fast. And we have definitely seen that. We've seen that really quite clearly. But this La Nina seems to be giving up. One of our indications of the strong trade winds is something called the Southern Oscillation Index. And normally if it's above a value 7, we're in El Nino. So we were there back in November. Excuse me. We're in La Nina. La Nina. Sorry, I screwed that up. But you can see we've gone down. It's down here as of Christmas Eve. It's below 0, meaning that the trade winds across the equatorial Pacific toward Darwin, so from Tahiti to Darwin, they're weakening. I've been looking for it. So if you go back to the month of November, this is 11/1 to 11/30, we can look at a lot of different kind of pieces of the atmosphere, okay? So for example, the top piece, the jet stream coming back. So normally we have very strong flow coming back like this when we are in La Nina. So where is it? Right over the top of the equator. What did we have back then? Well, yeah, look at it. This is your anomalous winds. These are your stronger winds on the top of that circulation. This isn't surface. This is way up at 250 millibars jet stream level. Very, very strong. And what did it do? It steals the momentum from the North Pacific jet. That's what it does. So it's all down here, okay? Now, if we go from November to December, take a look at this. This is now the new composite mean of the flow. And what's been interesting is that translation of what was going on in November resulted in a highly variable but retracted jet that then ran up into a big ridge here and then dove into this section of the United States around a big area of high pressure right here. Now, you know what this has done. This was why December was so dry. Most of December was so dry for California until the last couple of days. This is what sent all the flooding rains into the Pacific Northwest. This is what set up the Clipper track, which delivered Thanksgiving snows. It delivered early December snow. It just kept hitting these same areas over and over again. And this is the track that left the central part of the United States so very, very dry. Okay, and you say, well, why? Well, this is what typically happens when there is a La Nina. That's how they get this. Right? You get this big variable jet. Why? Because the momentum in the tropics has taken all of it. And we're just questioning how that's going to continue to go forward. Because since we've gotten into the month of December, I've noticed this. The anomalous winds are now significantly weaker. See how they're gone? I mean, look, I think go back. It's one before. Yeah. No, two before. There we go. See how strong the anomalous winds were here at the jet stream level? They are now like this. And what it's done is it's allowed, a big high to move here lately. And we've seen this high weaken. It's gone. It's gone now. We've gotten rid of it. And I think that is the part of the transition away from La Nina, which is going to get us out of this highly variable arcing jet here and move it somewhere else in the month of January. That's what I'm talking about. That's going to be the main change in this. Now, remember, there's a surface wind component to this as well. So can I show you this again? Now we're down here, trade winds. All right, the trade winds in November, there they are, very strong. In fact, we had these westerly wind bursts here with the negative IOD. Now watch this. Same color bar. That's November. This is December. You just watch right here. This is November, December. Those trade winds have backed off. They've slowed down. And that's one of our first indications that La Nina is beginning to give up. Now, what did it do? Without these stronger than normal trade winds in this area, this is an anomaly map again, we are now starting to see differences in where pressure patterns are living across the North Pacific, across the North Atlantic. And this is the one that I'm most focused on right now, this big Bering Sea high. If it stays there for a while, the atmosphere is not going to gain any momentum, and it's going to block the pattern up. That's what it's going to do. But that's our big question for the month of January. Does it start to slide here? Because the moment it slides through Australia, forgive me, I was talking to them last night. But if you slide this over, Alaska, and Canada. We will open this whole channel back up to very, very cold air at times. Okay. Now, I think, let me refresh this. I think that this La Nina is on its kind of last legs, and I'm going to tell you why. If you look, the response of the strong trade winds, so this would be the South American side, this would be the Indonesian side, let's put an I there, and this is the top of the Pacific Ocean. Now, when we have the strong trade winds like the arrow, we get this cold water upwelling. The fish love it, okay? The winds blow it across, taking the cold water with it, and then all the warm water piles up here and has to come down. So it ends up creating a circulation in the ocean like that. So there's a circulation in the atmosphere that does like that, okay, and a circulation in the ocean. Now, these are not drawn to scale. Again, this is Indonesia, and this is South America, okay? And this is only going down 450 meters, whereas this circulation goes up, thousands of meters in the atmosphere. Okay, what I want you to notice is this animation goes back to October. Watch this warm water. Can you see in November and now into December? See how it's edging its way closer? Now watch it again. Going back to October, November, December, and we're losing a lot of these colder water anomalies. Now I'm trying to tell you all this because I think this La Nina is making an earlier exit. Normally I'd watch it for another 45 days of maintaining its strength. I think it's slowly starting to decay. We've already seen a change in the strength of the jet stream level winds across the equatorial Pacific and the surface trade winds. And I think this means that we're not going to be able to use the second half of a typical La Nina winter to define this winter. Does that make sense? In other words, where did I put that darn thing? There. I don't think we're going to look like this at all going into a temperature pattern going forward. Now, we know that right now, there we go. Today's temperatures are very, very mild. Right? We're in the throes of these changes. That's Christmas Day. All right. We then get out here to the 26th, very mild. Look at this, 80s, holy cow. That would be the 27th. Watch this, ready? That's now Sunday. This has trended much colder in recent model runs. This is Monday. Low temperatures, we're going to push a frost down here, pretty far to the south. So this swing in temperatures was only recently, I think in the last 4 days, picked up by the longer range models, and now here it is showing up in the near term. And you probably heard a lot of folks just say, winter's over, canceled. You just got to be careful because what happens when you transition out of one big regime like La Nina to something more close to neutral is the atmosphere is going to heave itself into more comfortable positions. And as a result, the heaving is what ends up redistributing temperature and precipitation across the whole world. So with all that being said, watch this. Remember how earlier this week on Monday, I said, hey, look, some of the weekend model trends suggested that the longevity of this warm air is not quite like what you think. Yeah, I think it's staying here. That was my point. But if you look, that's the next 5 days. Look at day 5 through 10. We watched the models just trend back into an open shot of colder air. Some of it's coming on Sunday, Monday, Tuesday of next week. It's going to get all the way into the southeast. And we're going to stay mild farther to the west, including parts of the plains. Now, it's going to seesaw back and forth the first week of January, going mild. But what I would expect is, again, as that high pressure tries to nudge its way this direction, it'll come out again. We'll put that cold air back into place. That seems to be what this pattern wants to do. All right, so I just want to give you an explanation as to why during this transition time period out of La Nina toward a new regime, we're going to have to watch a lot of simple subseasonal things, try to stitch them together into one more complex story. All right, with all that being said, what is it doing to our precipitation? Well, yes, it's game on in California. Deep lows. We have one today. There's another one coming on Friday. Massive flooding threat. You've already seen a lot of the flooding going on there. We know that our main snow corridor is here, except for what's in the Sierra Nevada and parts of the Central Rockies, which need every single inch of what we can get them at this particular point. We are quite dry in the central, southern United States, in the southeast, but the northeast continues to see more and more risk of getting some snow. And I want to show you why that's happening. Here we are now. This is what the jet stream looks like, running around these troughs and ridges. As we work our way through Christmas, getting out there to Saturday, Sunday, that is the low that's cutting through, that's dropping these temperatures, and it gets deep. Look at that. And then it's reinforced as it exits with another low here. And watch this one sneak around through the Great Lakes. And that one's going to be interesting to watch up the East Coast as we approach Christmas. We're still very mild here. California, you do get a break as we approach the new year. But as we get out there farther, January 2, 3, 4, 5, look, we continue to reinforce this trough. But I'm just curious, what's going on with this ridge? Why is it, is it weakening? Is it changing? Are we going to be able to let this cold air out at times? Because there will be surface high pressure under this, and that's what I want to know about. And I'm going to come back to that again at the very end. All right, as it stands, that system coming into California, this is just the first one. The second shortwave is on the backside, and it's dipping way down here. So watch this come through. There's your second shortwave right there. And this is just the onslaught of moisture throughout the depth of the atmosphere getting shoved into California right now. We do have widespread winter storm warnings, high wind watches, advisories, flood watches farther to the south. This is a very, very rough system moving through here. We've already seen just in the last 72 hours all the flooding. I mean, we're going to have to watch this whole region very, very carefully as we go forward. And you can see here already how much heavy rain has hit that section of California. Looking at some recent radar data, some of this rain moved through parts of Arizona. And then here comes the next big push. This was late last night into early this morning. And this is just one of two big systems to finish off this week. Now, wind-wise, we are looking at very strong gusts expected throughout California. This is just a forecast through early in the morning on Friday, looking at the potential wind gusts. Now, this will always be driven by topography as well. It's one of the complications of forecasting winds in the west. But you can see the potential for gusts 50 to 60 miles an hour, enhanced by topography, very strong just offshore as well. Now, that is not to ignore the winds again we see coming down slope here off of the mountains in Wyoming and parts of Colorado as well. So we must be paying attention to those as well. But let's just take a look at this system. It's kind of the only game in town except for some snow right now in parts of the Northeast. So the deep low rolls through this morning, getting into this afternoon and evening. There you go. And then we're going to watch this next system on Thursday. There it is, 2 a.m., 3 a.m., 4 a.m. Central Time. There it comes into the northern California. More snow in the central and southern Sierra. And this system just rolls up on Friday. So again, just watch the West Coast. One system now, a second system on Christmas into Friday. We do have to keep an eye on a little clipper that's rolling through the Great Lakes in Ontario, right in through this area. But we'll give you a bigger perspective on that in just a second when I show you the combined forecast here, the GFS and the European. What I do note is I only had one real spot to talk about, and that's the west. The pattern is very much meridional rather than zonal right now, and it's leaving the central part of the United States very, very dry. Same thing for the southeast. Now, I'll show you what's going on in the northeast in just a few seconds, but my concern is these are now the month-to-date statistics, and I've now got at least 3 climate reporting districts right in through here that are having their driest Decembers on record. Remember, these records go back to 1893. This is going to change significantly with the next two systems, but a lot of the Pacific Northwest is extremely wet. We're just keeping an eye on this pattern across the country to see how it changes. Now, with the mild air that's melted all the snow that's gone up into parts of the Midwest, look at the Mississippi. It bumped up just a hair. We went from about -8 feet to -1 feet right now. So there's been some water that's come down the river. But overall, if we look over the next 10 days, it's going to take a while to get this pattern to change. We do see a pretty substantial section of the country here in very dry conditions in the central U.S., extends throughout the Great Plains and also in the southeast. Okay, now let's compare the models. GFS left, European right. We've watched the two systems coming into California. There they are. We then notice the clipper that's coming through on Friday that's going over the Great Lakes. There it is. Look at that. It's going to be some rain. It's so mild here. Rain till you get way up in northern Wisconsin, UP Michigan, or north central Michigan. Watch that system go into the northeast. Now, this is going to be an interesting snowmaker. Coming across Lake Ontario into parts of Pennsylvania and New York. And both models are putting down the risk of ice. Now, where are we in time? This is Friday night. We just need to be very aware of this. That's a big travel day. Now, our next big system hits the west, and then it just sends a wave across the country, and a low spins up here, and there'll be a front, which is why we're watching on Sunday for the chances of rain here in both models. But can you see the GFS doing a rapid turnover to snow? There's brutally cold air coming behind this on Sunday. Very, very cold air in the upper Midwest, and there's going to be some snow and stronger winds with it. Then that system curls up into the northeast, and this is where the models early Monday morning have a much different scenario on where the snow rain line is going to be. Now, we're going to have to watch that all weekend to see how that pans out. That system then exits, dumping a lot of snow in Maine, on the backside lake effect coming through. And what's very interesting is with all this cold air that's going to be spilling in, the European model is trying to throw down some snow in New Mexico and Texas. So it's just along this front, but you can see the colder air in place. Let's now play to December 30th and get all the way out there to New Year's Eve, and we're back at it. So you don't see it in the GFS, but look. There's another little clipper coming through here that we're going to watch for on New Year's Eve. And where does it go? Straight into the northeast. I'm looking over here at the European solution in this case. So we put it all together. We mentioned some snow. By the way, let's go do this first. I've been working on this new thing. Where did I put it here? There we go. And I just want to show you the total precip from my new system. Again, this is not live. I have to manually update it because I haven't put it yet on my cron tab. But that's the European solution for total precip for 15 days. I'm excited to get this live for you in the new year. Man, look at that. I like this. I hope you guys like it too. But let's come back to the snow. Where was that? There we go. Don't forget, on the main site, we saw our static maps of looking at all the snow. I did pull off the European model 10-day because I wanted to see just how much it was putting down in parts of Pennsylvania, New York, upstate sections of Vermont, New Hampshire, and most of Maine. Very, very heavy snows. But mainly the corridor is here around the sizable ridge. But remember, there's a front that gets through this, and that's why the Europeans got some snow down here. We just need to watch this, okay? Again, when was that? My brain has already forgotten. There it is. It's Tuesday. Next Tuesday, okay? What about GFS? They're both huge on the snows in the Sierra Nevada, more sparing here in the snow events going on in the Central Rockies, which again, right now, the Upper Colorado Basin is the second driest, and compared to the last 10 years, only 2018 was drier. Again, one of those analog years I'm hung up on, but very similar snowfall forecast through that corridor. Okay, probability of snow, let's just look at this too. There's the chance at 1 inch for the next 10 days. I'm really kind of looking down here to see if the models are seeing it, but that corridor seems to be pretty solidly predicted. This is now the chance at 6 inches. Just find your area and have a look. Look at this, 12. Yeah. And 18. Now we're just mainly out west. 24, 36, 48. Yeah, we're talking 100 plus inches of snow coming into parts of the Sierra Nevada. All right, week 2 precipitation. You'll see them right here on the AgWeather website. Are we breaking this thing down? It doesn't seem to be fully broken down as we finish 2025 and get into 2026. I think it's just going to take a little more time than that. But you've already started to see the changes taking place upwind, upstream, which would be out in the Pacific Ocean. So what about back to the temperatures? Well, here's the frost forecast for the next 7 days. And I'm just pointing this out to see how far to the south it makes it. Okay. And then you've seen this. There's your next 5 days. But watch as we get past and include more of early next week. See that cooler air come diving in here day 5 through 10. And this has been one of the most remarkable trends we've seen in December here. Remember, earlier in the month, this was all predicted mild to finish the year. And now we've kind of analyzed that and seen, we talked about it on Monday, why this is going over colder. And sure enough, we're able to let some of that cold air out. Now, what's it going to do? It's going to seesaw. Ready? Back over mild. And that gets you out there to January 8th. And guess what? We think mid-month, boom, it comes back down again. It's just going to do that for a little while as we start to see things kind of readjust. You can even see it when we go look at the European weeklies. By mid-January, what have we done? We've got high pressure in 3 spots. And all that high pressure across the northerly latitudes is going to start to displace and shift where we're going to be able to put cold air. I am going to watch one area of high pressure fade at the expense of the North Atlantic, Greenland, Iceland high pressure start to form. And the net effect of that, if I show you the temperatures, is this. Let's just take you back. That's January 10th. Here comes the mid-January cold shot again. See it? See, the model's doing the same kind of seesawing back and forth with temperatures. So just be prepared for it. It's going to go up and then right back down. And we're looking at the chance of being quite cold here to finish January. Now, that's not typical of our most recent La Niñas, right? We had more mild air at times in January, February, March here, and now we're kind of seeing this. I think it's just important to point out. If we zoom in on the United States and just focus on precip, let's just look at the January forecast on precip. There it is. What has trended a bit drier is here, and also Southern California. Outside of that, most everything else is very similar. Now, what I want to know, and this is where things are really going to start to get a bit loopy, is this. Remember how we just showed for weeks like, oh, it's just blue straight down like this? No. Now at the end of the month, some sort of western U.S. ridge is coming in, eastern U.S. trough. That's the cool down. Then we go back over, like here, beginning of January, cold west, mild east. But I think it's going to flip again mid-month. That's what I'm really trying to get out of these. The European model is also giving some clues that we could start ourselves across another MJO transition to finish this year and start the new year. And I think the Bureau of Meteorology has probably seen it best. So we're in phase 1 now. We expect it just to curl around. Question is, does it keep doing this as winter goes on? Because normally a La Nina winter holds it hostage somewhere over here. I just don't see it. Now, what's the point of sharing all of this? The main reason why we diagnose all of these things is to come back to this. Looking down on the North Pole, we know that we've seen in the forecast strong zonal winds doing this, right? So starting in like the Sahara, coming across huge sections of Asia, zonal. But then what happens is in the North Pacific and in the North Atlantic, things are quite loopy. And what we are wondering is if any of the transitions I started off talking about or finished talking about is going to get this to zone back out again. That's going to be key. Will that happen at some point in January, February, March? We have to just wait and see. But losing La Nina would be critical to getting rid of this. Now you're going, what is that again? That is what typically happens. Where did I put that darn thing? There. That's what typically happens in a La Nina. We just tend to get this, which we're in right now. I'm just thinking that we're going to change this up in a big way later in January and February, and we're in the throes of the change right now. That's it. That's my main story with all of this. So with that loopiness, we've lost momentum. We built it up in November. We've lost it in December. I think it's going to come back up again, giving us this seesaw nature through the month of January. All right, I've only got one last thing to talk to you about, and it's the same story. We know that we were going over drier here, but earlier in the week we analyzed this, right? We're not hurting for precipitation except for in a few small spots like in Goiás. There's a couple of drier spots. It's not to say there aren't other areas, but the next 7 days is drier here and very wet in this corridor. Now, if we take it out to week 2, there's week 2, we see the models returning rain during that time frame. My biggest concern for South America is if you are south of this line, so that includes Buenos Aires over toward Cordoba, they're looking at a pretty dry start to, the astronomical summer. And with that, there's expected to be, warm conditions. And so we're getting concerned about what this might mean. See that? Yeah, sorry, let's take it back to week 2. See that heat coming into this area? Just something to be on the lookout for as we monitor this situation in South America. Otherwise, with high NDVI, which I showed you on Monday, and then recognizing that, coming back to the precip chances, that Brazil's going dry, then wet, that's that regular change that's keeping this crop looking really good across most of Brazil. I imagine you'll start to see the estimates just continue to tick up on the size of the soybean crop. When we get into the new year, we will analyze hard the forecast for the safrinha crop, which I think is going to be critical because it's very difficult to stretch 6 to 7 straight months of incredible weather across these areas. And I think we just need to have a discussion about what that might look like. Okay, that's it. You all have a good, safe holiday season. I will talk to you on the other side of it. Please just travel safely, and we'll talk soon. Thanks.